question 2 of our practice test, we have a bit of information here, and I'm going to go straight into my questions because basically I can still read this a bit later on. I'm going to start off with, what is the molar mass of hydrogen sulfide? So I need to know what hydrogen sulfide is, so I'm going to start reading this. Hydrogen sulfide, here's a molecular formula for it. So what is our molar mass of H2S? And again, notation helps because it tells us that we know what we're actually calculating here. So if you can say molar mass is MR, that equals, well, I look at my periodic table and I work out that I have 2 hydrogens, which are both 1, and I've got a sulfur, which looking at my periodic table here is 32.1. So my molar mass is going to be 34.1 grams per mole. The unit is relatively important because, units are important, as I said, and the unit for molar mass is grams per mole. Determine the number of mole of hydrogen sulfide present in a 1 litre gas at the lethal threshold. So what I need to do is read up here and work out what the lethal threshold is. So what does it say? Hydrogen sulfide is a toxic gas with a lethal toxicity to humans at concentrations of 800 milligrams per litre. Okay, so therefore this is a lethal amount. So in 1 litre of gas, that means it's 800 milligrams. So 800 milligrams is what I want. I need to know number of moles of hydrogen sulfide equals M over MR. So that equals my mass. My mass here is given me in milligrams, but in my formula here, my mass has to be in grams. So 800 milligrams is 0.8 grams. So I'm going to take 0.8 divided by my molar mass, which is 34.1, and that's going to be equal to 0.8, whoops, let's go 8 divided by 34.1, that gives me 0.0235 mole. Again, I'm taking about 3 significant figures. I'm making sure I round based on my 4th there. Deduce the number of mole of hydrogen atoms in the gas. So I need to know number of moles of hydrogen gas. Again, notation comes first and then thinking about what happens comes second. Now I know I've got this many mole of molecules, so my number of moles of hydrogen is going to be equal to my number of moles of my molecules times by 2, because in every one of these there are 2 hydrogens. So therefore if I had 1 of these I would have 2 hydrogens, if I had 2 of these I would have 4 hydrogens. Number of moles of my molecules times by how many of those atoms there are there. So 0.0235 times 2. Now this is where it gets a bit funny because I go to my calculator, my answer is still here. I'm not clearing my answer in this. I'm simply taking my answer and timesing it by 2. And that gives me 0.0469 mole. This is one interesting thing because you can see here, because I rounded this, if I cleared my answer, I would actually get 0.27. But because I didn't, I actually get a more accurate number. That's why I use the term answer on my calculator. And it's actually a lot quicker as well to use my calculator that way. Anyway, let's move on. Calculate the mass of sulfur present in 1 litre of gas. Assume all sulfur is present as hydrogen sulfide. So what I need to know, again, notation comes first. My mass of sulfur equals number of moles times molar mass. Now I need to then work out what my number of moles of sulfur is. So I know my number of moles of these molecules is this. That there's 1 sulfur in each molecule, so my number here is that. My number of moles of sulfur equals my number of moles of hydrogen sulfide. So that's 0.0235 times by my molar mass, and that's of sulfur, which is 32.1. So therefore, I go here. Now remember I said I didn't want to use this rounded number. I'm going to go back up here. I'm going to go 0.8 divided by 34.1. That gives me my accurate number with all of the significant figures, all the digits, and then I'm going to go answer times 32.1, because that gives me a more accurate number, and 0.753 grams. And again, you can see going through all my working out here, I've got units attached to all my numbers. I've got notation which tells me what I've calculated, and that's the important thing about doing these mole calculations. Let's go on to question 3.